Hello guys, welcome to Algo Insights. Today let's go to the next problem in lead code, add two numbers. This is a medium complexity problem, so let's get into it. The problem description says you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume that the two numbers do not contain a ring leading 0 except the number 0 itself, which is good. That has clarified a lot of stuff in the problem. So the example that they have given is 2, 4, 3, and the second linked list has the values 5, 6, 4. And how do we sum is the values 2 plus 5 is 7, 4 plus 6 is 10 with the carry of 1, and the carry is added onto the next node in the linked list. So 1 plus 3 will be 4 plus 4 is 8, and that is our answer 708. So this is actually good because in regular m- mathematics addition, if we have the number like 2 plus 4 plus 2, sorry, 2, 4, 3, and the number 5, 6, and 4, we actually would get the answer as 7, 0, and then there will be a carry 8. So our answer will be 807, which means we'll have to reverse. But in this case, that's not what is expected. So we have to return the numbers as 7, 0, and 8, which is good because we just add the numbers. If we have a carry, we just add it to the next node in the linked list. So let's get into the solution. Basically, we are going to get two list nodes. So list node L1 and list node L2, and then result is also going to be a list node. So that's what we have to return. So let's get into it. The approach that I'm going to use here is I'll create a result list node with a default value, a dummy value into it. And then we start adding, we iterate through each of the list nodes L1 and L2 and just start adding the values. And finally, we will return the uh, dummy list node, I mean the next of the dummy list node. So once we get into the editor, it will be much more easier. Let's get into it. List node, I'll say result list. And this mentions that we have non-negative integers, so I can, it's a dummy value. I can just safely assume a value of -1 to that. And then I need to just hold a pointer to this. So a list node dummy, I'll say. And this will common in many of the linked list nodes problem where you basically take a dummy and then return the value, the next pointer of the dummy. So right now this is pointing just to the head of the result linked list. And then let's have a carry. Carry, we'll need a carry. And we have to iterate to the linked list anyway. So let's do while L1 is not null or L2 is not null. So we'll just go through both of them. 2 is not null. So while either of those two list nodes are not null, we will take the values of them. So let's do for L1, let's take the value as val1, and this is going to be L1.val, and val2 is going to be L2.val. In a in the future iteration on the loop, there could be a case when L1 could be null and L or L2 could be null. So in that case, this condition will break. So to fix that, uh, we'll have a simple check. L1, if it's not null, then we will have L1.val. Else, what we can have is a 0. what I have done. Okay, if my bad. So if L1 is not null, then we'll take the value of L1, else we'll take the value of 0. Similarly, L2 could become null in an later iteration. So val2 will be L, L2 is not null, then take the value of L2, else have a value of 0. And now initially what we can do is we will need a sum. So initially our sum is going to be equal to the value of carry. So it will be 0 for the first iteration and subsequent iterations if we are not having a carry. But if we have a carry, initially the sum will start with a carry. And then what we'll just have to do is sum plus equal to val1 plus val2. And the number, the digit in the linked list node that we will be creating is, to get that digit, we will have to mod the sum with 10. So I'll say int digit digit int digit is equal to sum mod 10, and we can have a carry which is going to be sum divided by 10. So basically I'll explain this how it will work. So for example, we have 2 plus 5. So 2 plus 5 is equal to 7. In this case, the digit is going to be 7 mod 10, 7 mod 10, and the carry is going to be 7 divided by 10. So the digit value is going to be 7, and the carry in this case is going to be 0, which is correct because this carry will be 0 and we have a 0 carry forwarded to the next iteration. And then we just need to have the dummy linked list dot next dot next will be equal to a new node, a new list node, and the value is going to be the digit. And then we have to also get, oh, I think my bad. What we have to do really is result list dot, because I'm going to finally return the dummy. So result list dot next node is going to be the list node. And then we have to also, now we have a node in the result list, but we also need to get to the end of the result list so that we add a node that at the tail of the linked list. So result list is equal to result list type result list dot next. And now if because we are in the first iteration, we know that we'll have to just set L1 equal to L1 dot next and L2 equal to L2 dot next. But in the subsequent iterations, there could be a case where either L1 or L2 has become null. So we'll just add a case. If L1 is not null, then L1 equal to L1 dot next. Similarly, if L2 is not null, L2 is equal to L2 dot next. We keep doing this till we exit the when both L1 and L2 become null. At that point of time, our result is really ready. There is only one small thing pending, that is in the last iteration of the loop, we could have a carry. So we just need to check after we complete this loop is if our carry is greater than 0 in the last iteration, we'll just have to add the same thing. So result list dot next is equal to new list node of carry. That's it. And then we finally return this dummy, if you know, is still pointing to the head node here. So what we just have to return is Nichan dummy dot next. Okay, so let's go through the example. We have 2, 4, 3 and 5, 6, 4. Okay, 2, 4, 3, 4, 3 and 5, 6, 4. So in the first iteration, L1 is not null, L2 is not null. That's true. 2 and 5 are not null. What we are going to do is just the carry is initially set to 0. So our sum starts as 0 and then the value of sum is going to be 2 plus 5, which is going to be 7. So the digit becomes 7 and the carry becomes 0. In the next iteration, carry is still 0. So value 1 and value 2 is going to be 4 plus 6, which is going to be 10. In this case, the digit is going to be 10 mod 10, which is correct. The digit is going to be 0 and the carry is going to be 10 divided by 10, which is going to be 1. And that's correct. So in the subsequent iteration, in the third iteration, the sum begins with the carry of 1 and then we just add the values of 3 and 4 and we get 8. So I think this should be working. Let's try. Okay, perfect. It works. And we also have a solution where, I mean, an example where L1 and L2 both are 0. So let's run that test case here and then we will just submit the code. So L1 is 0 and L2 is 0 and let's see, run the code. Okay, so the test case pass and we submit. This should work. Okay, perfect. So this works. Let's go back to the solution again. Uh, The time complexity, I think it's fairly easy to understand that we are going to go through the linked list individually, both of them. So it's going to be O of n. And the space complexity, I mean, I don't think we consider the space for the return values because we have to return the list node anyways. So I would fairly say that the space complexity is going to be constant because what we are creating is just some variables. Thank you guys for watching the video. Have a good day ahead.